Hi everyone. So as Alexis said, today we're going to talk about mixed reality on the web. So let's start. First of all, I would just like to say a couple of things about me. So I'm working as a front-end engineer at Ava. It's a Berlin-based startup. And I'm also doing my PhD. So everything I do regarding mixed reality, AR, VR, is mostly for my PhD. It's not something that I do in my company. I'm also one of the lecturers at a regional group named DAFED. We also organize tech events. And I work as a book reviewer for Manning. So if you ever read any of the books related to JS from Manning, I'm probably one of the reviewers there. So I also, of course, love JS, and this is why I'm here. So that will be it. So today we're going to cover a little bit of the history, how did we got here, what steps needed to be taken so we can actually do VR and AR on the web. We're going to talk first a little bit about Webgl and Three.js. We're going to talk about Visual Studio Code, mostly about some plugins that you can use for Visual Studio Code. We're going to import some 3D models, create a VR scene, after that create an AR scene, and we're going to talk about WebXR, or what is the future of mixed reality on the web. So this is some statistics that it's very interesting for me. It's forecast about the market size worldwide from 2016 to 2022. It's kind of projection. So this is in billion US dollars. So you can see in 2016, VR and AR market was valued at $6.1 billion, and the projection is that in 2022, this will be $209.2 billion. And what goes after that, I mean, who knows? So this is current state. You can see that it's $27 billion in 2018. So if you're not in VR, AR, you can maybe consider it. Maybe it makes sense. So kind of skills and tools, because my talk here is interactive, so all of you are going to be participants. But also if you decide to take a look at these examples that I'm going to show, you can do that with some basic JavaScript, HTML, and CSS knowledge. Everything is hosted on my GitHub, so you can actually run all of the examples locally when you get home, if you find it interesting. I really hope you do. I'm using Visual Studio Code here, but basically you can use any other IDE. I'm using Visual Studio Code because of some plugins that I find very useful. And I'm using Chrome browser, but of course that's your preference for these examples to work, because we're using resources, external resources. Basically you need to run a local HTTP server. I'm using the one from Node. You can use the one from Python. It doesn't matter. So yeah. So short history. Webgl was the first point. So it represents a web graphics library, which is basically a JavaScript API. It enables us to render interactive 2D and 3D graphics. Basically right now, it works with basically any modern web browser, but when it started, it wasn't like that. It wasn't that easy. Of course, in 2006, Webgl evolved out of the Canvas 3D experiments, started by Vladimir Vukicevic. I really like to mention that because he's Serbian, as am I. And after that, that was taken from Kronos Group, where he moved later. And in 2011 we got a first 1.0 Webgl specification. Right now we're on version 2, and it's supported in basically all major browsers, both the desktop and mobile. Three.js is basically a library that allows us to create a GPU accelerated animations. It heavily, of course, relies on Webgl. And as Webgl is not really easy to use, Three.js abstracts some of the functionalities that Webgl has, and it allows us to create a little bit more elegant solutions faster. So it was released in 2010, and right now, like, it's more than 96. I think it's almost 100 now, stable release. A lot of contributors on GitHub. So now we come to this part. Because, as I said, like, my demo is going to be interactive, I hope you're all connected to the conference Wi-Fi, HolyJS. If you're not, the password is HolyJS 2018, lowercase. And if you don't have a QR code scanner, you can actually type in the address. It will ask you, do you accept a certificate, which is not secure, because I'm running it locally. You need to accept it. If you don't want, I understand. I'm not gonna hack you, I'm talking. But yeah, so you should be able, I hope everyone got this scanned. I'm gonna wait, yeah, sure. So you should be able to see something like this. So don't start clicking. We're gonna go to the examples. So the first example is to demonstrate a basic usage of Three.js. I'm going to show you how we do it in the code, and I'm going to show you how the example looks like. This is just creating a simple cube that rotates, so you can actually run this on your phones. You just need to click on the example one. There's also a link here to the directory with the code on GitHub. So basically, if you run this on your phone, it should look something like this. Yeah? Cool. So it's basically just a green cube rotating. Yeah, nothing special here, but let's see the code. So if you open this on my GitHub, you'll basically see a directory with a couple of examples. We're going to go over them today. So first is the example one, and everything is in the index.html. It's not like I'm afraid of JavaScript files. I just wanted to make it a little bit easier here. So you can see that this is just a basic HTML, just a title and some CSS to set up the canvas size. The canvas is the place we're actually rendering to. And we're including the Three.js library. In the script tags is basically where all of the code is for this scene. We're basically calling Three.js scene method, which allows us to create the scene where we put all of the elements in. Like we put our geometries, we put our lighting, whatever we can think of, we put it in the scene. We're also creating a camera, which is a perspective camera here. Basically, the camera is your, how do I say, viewport. So like basically where you're looking at is where the camera is actually pointed at. And we're creating a Webgl Renderer. Basically, a renderer is a place where we combine our scene with the camera and we enable these animations. So we just, after we created a renderer, we set a size and we just append it to the document. So we just add it to the DOM. For the first example is a basic geometry, so we just create one simple box and we just add some green color to it. So we're using mesh basic material. Basically, Three.js has different kinds of materials. This is just for this example. And with 3mesh, we combine the geometry and the material to get the cube as is the one that you're seeing. So in the animate function, which we basically invoke as a callback, there's a request animation frame. So the request animation frame basically tells the browser to call a specific function to update the animation before the next repaint. So it takes an argument as a callback, so you can always call it in a loop. So like the number of calls basically should be the number of frames, but it's not always the case because it depends on what you're actually doing in the scene. So you can actually see what I'm doing here is I'm changing the X and Y position of the cube, and I'm doing it iteratively, and that's how we're getting this animation. So it's quite simple, right? So what we wanted to do now is to import a 3D model into our scene. So it's very interesting how this is being done. Like Three.js also has support to import OBJ and material files, also other formats, of course. Like if you're using something else, you can probably import it in Three.js. I have to say, like, I'm not an expert in 3D Max or Maya or anything, but I can do it enough to create something and export it. It doesn't work always. But here I'm using the Visual Studio Code with 3D Viewer for Visual Studio Code. So now I'm going to show you how this works. Like generally, most problems that I'm having when I use Three.js or external models that I'm importing, I usually have a problem with not being sure if the model is properly exported, because if you're using some other plugins in 3D Max or something, the model could have some mistakes, and then I spent a long time figuring out what I did wrong in my code, and the model was improperly exported. So in the Visual Studio Code, you have a really nice plugin called 3D Viewer for Visual Studio Code. It's free, of course, which actually runs on Three.js. You can actually, when you install this 3D Viewer for Visual Studio Code, you can click on your asset. So like all of the assets are in the assets folder. We're using end obj file. Right click and open in viewer. So here we get this shape. So what this is. Okay, so this is how the model looks like. This is how it's been exported in space with x, y, z coordinates set. But if I move like here, you can see like it has some HolyJS written. I can actually navigate throughout this scene. What you can see here is there's no material applied. Right now, a plugin has some issues with materials, but for me, the most important thing is the OBJ. So I can actually see that this model can be imported into the scene. So when we go to the example 2, we can see this. So if you try it on your phones, it's not reacting to touch, it's just on mouse, so you probably cannot move it. But if you wanted to move it, you can do a pull request or something. Okay, so let's take a look at the code. So now everything is in the script.js, so in the index.html, there are basic things. Importing the Three.js library, importing the material loader and obj loader. So I need these two loaders here because I'm importing obj file and I'm importing material file for the texture of the imported 3D model. Basic CSS, I don't have to go over that. And yeah, that's it. So in the script.js, we have, of course, an onload. You can do it differently. Some basic variables that I'm using just to control the scene. Nothing special there. Again, what we're seeing here is, again, we're creating a camera and we're creating a Three.js scene that we use to add all the things like lights, cameras, and objects. We're using two different lights here. So we're using ambient light and we're using point light. Ambient light just globally illuminates all the objects, so it doesn't cast shadows, while point light is basically we tie it to our camera, so you can imagine like a flashlight connecting to your head, and like wherever you point, I point that light, so it casts a shadow, like a light bulb. So after I've created these two lights, I add the point light to the camera, so that's how I'm getting this effect. This is something I just used to make sure everything has been loaded properly. So how this works is, first I need to load my textures, which are in MTL file, like the material template library format. And it basically describes the shading and like colors of the object. So after the material has been loaded here, I can use it in the object loader, obj loader, to set the material for the loaded object. So this is the obj file that I'm loading, and I'm just setting a position of the object in space. So you can actually see here that what I'm doing here is I'm rotating the object on X axis. So why am I doing this? But like you saw when I showed you this mesh preview, that the exported object is flat down, face down. So I have to actually move it up. So I have to do this rotation. If I do it without the rotation, it will still be flat down, so you won't be able to see what it says. Like you'll have to go under it. Here, what is commented is just like some nice way you can actually manipulate the material through the code, like without the textures. I'll leave that up to you if you want to play around with that. And I just add the object to the scene. So now what we did is we've created an object. We had we loaded an object, we applied a material on it, we added it to the scene. So what's left to be done is to do some animation here. And as you saw here, like as I move my mouse, like we can have some interaction. So what is happening exactly here is that in the animate function, we're basically getting the position of the mouse and the current position of the camera. And as I'm moving the mouse, I'm setting new coordinates for the camera position. So actually, I'm not actually changing the position of the object, I'm changing the position of the camera, so it looks like the object is actually moving. You can do it also vice versa. You can do it with the object. So basically, right now, we've seen how to import a 3D model onto our Three.js scene. So where is VR in all of these things? A-Frame, as a web framework for building virtual reality experiences, relied heavily on Three.js. So it was developed originally from Mozilla as an easy way to develop VR content. It currently supports different headsets like Rift, Windows Mixed Reality, Gear VR and cardboards, all of these things. And it's based on Three.js. It has a full access to its API, so it kind of adds a new layer of abstraction on top of Three.js. Generally, A-Frame allows us to create a very simple VR solutions, very easy. For anything more complex, you would have to generate your own entities. We're going to go over some simple things here. But it uses this declarative HTML, so you can basically have like components that do just a couple of different functionalities like camera, boxes. You can add the sky, you can add a surface, you can do pretty much anything you can think of, but it has a predefined number of elements. So if you want to create a custom element, you have to do it by yourself. Like what I did for my PhD is I created VR-enabled map that should be in AR now. So like basically do Google Maps or whatever maps you're using. I'm basically taking this and casting into VR space so you can actually navigate through the map in VR or AR. And I did this by creating my own component. So like it's not so simple to do this part, but for some easier things, it can be pretty much interesting. Of course, it's a cross-platform VR, which is the biggest selling point of VR and AR on the web. You don't have to do programming for some proprietary software. You don't have to create a solution that can only work on Oculus or that can only work on HTC. We're doing this for the web, and it should work everywhere the same. And I'm saying it should. It doesn't mean it does work, but we're getting there. Performance, generally, like if you're not doing some high-intensity things with the canvas, you can get up to 60 frames per second, no problem. But like as I said, it depends what you really want to do with this. So now we're going to take a look at the example number 3, which is a basic A-frame scene. It has a couple of elements that are displayed on a plane with a sky. So if you're running this example on your phone, it might be the case that it has a little bit some wobble effect. It's kind of shaky. It depends on the IMU, the quality of the IMU in your phone. So if the gyroscope is pretty sensitive, it will really be shaky. You really have to hold your phone steady. Like on some other phones, it works really nice. This is something that will have to be fixed in the future. Here we're going to see how to work with Visual Inspector, which is an awesome tool integrated into A-frame that allows us to manipulate 3D objects in A-frame basically interactively while we develop our solution. So let's see how this works. So as I said, like here we have a simple plane, green plane, with a cylinder, a sphere, and a cube. And we can look around it. And this is something you can do with your phones. When we're talking about VR on the web, the solutions developed for it always have this cardboard glasses in the bottom right corner. So if you click on it on your phone, it will split the view. So it will already be ready for VR. If you do this on a desktop browser, it doesn't make any difference because you cannot put your monitor into sunglasses, or I haven't seen that. What you can do here is basically 3 degrees of freedom. Like as you move your head, this is basically what you can do. 6 degrees on freedom you don't have on your phones right now. Please don't try it to walk around with this. It doesn't make any difference. But if I do it here, well, like with my keyboard, I can actually move around the scene. So you can actually go anywhere you want. So, as I've said, like Visual Inspector is a tool that comes very handy when developing these kinds of solutions, because you might want to set up initially objects on your scene on certain positions. Doing this like from your head by memory or something doesn't make a lot of sense. To set up X, Y, Z coordinates, it will be just plain guessing. So Visual Inspector comes in handy with this. So you can actually use a shortcut to start it, Control-Option-I on the Mac. And we get the Visual Inspector. So if you ever did something with game development or Unity or something like that, it looks kind of similar, of course, with far less functionalities. But here you see how your scene actually looks like from a different perspective, and you actually see what is the position, the initial position of all of the objects in the scene, but also the position of the camera. And in the Visual Inspector, you can actually interact with all of the objects that are displayed here. So you can actually take this sphere and you can move it like with all 3 axes. But you can also move it like this. And while you're moving it, in the right part of the screen, you see which element this is, and you can see the coordinates for the position, rotation, and scale of this element. So you can see as I'm moving this in the upper right corner, these coordinates are changed. So you can actually just add elements to your scene, and then with the visual inspector set up initial positions of the elements. So this actually works, of course, for all of the elements that are here, but it also works for the camera and for the lighting. So you can actually play around with this. Okay, so we've seen how code in Three.js looks like. This should be a little bit more complex, right? But when we open the example number 3, this is it. So this is basically the entire code that runs this example. So how does this work? Well, it uses A-frame. So we're loading the library, of course. That's basically it. So A-frame in the background loads Three.js, which uses Webgl, of course. And here in our HTML, we basically do all the coding, which it's declarative pretty much. So every single element that's going to be rendered in our VR scene needs to be in these ascene tags. So basically what we do is we place our box, we place our sphere, we place our cylinder, our plane, and sky. And we just set some initial properties on these objects, such as the position, rotation, color, height, width, whatever we want to do with that element, of course, whatever properties it has. So here, I'm using elements that already exist in the A-frame library. So you can basically do these things yourself. You can add more elements, you can set their position however you want. I advise to use Visual Inspector for these things. And that's basically it. So if you want to do something like add a text, adding text isn't so easy how it might look. Basically, you cannot use normal HTML in the A scene. Like, it has to be an A-frame entity in order for A-frame to recognize it and to use it. Like, if you add something, let's say, below the A scene, and if you shifted the scene itself as a canvas, then you will be able to see this element. But it doesn't make a lot of sense. You would want your text displayed in the A scene. So there are other elements you can use, or maybe you can create some of your own custom elements. So we've seen how A-frame works, some basic functionalities of it, but now let's add our 3D model. Let's add it to our A-frame scene. Basically, it looks pretty much the same. It's similar, but now we're using elements that we actually don't have. So we're loading our OBJ files. So we can take a look at how this looks. This is example number 4. So this is our HolyJS logo, and this is our VR scene. How we know it's VR? Because of these glasses. So we can actually move around the scene. And interact with it, maybe if we set some event handlers. But on your phones, as I said, you can only do 3 degrees of freedom, so you can do only this. So let's see the code for this. Again, we're using the same OBJ file, like the same 3D model that I shown previously in the example number 2. So this is the code. It's even less elements than before, right? What we're doing here is we're loading our assets. So A-frame has a special way of how we load assets. we're using a assets tag, and within it we use a assets item, where we assign all of our assets some ID that we later use once the assets are loaded, that we use to integrate it into our A entity elements. So basically, with this ID, your OBJ and your MTL, we add them to our A entity element. So here we can see that A entity element has an attribute with OBJ model, so we can add the ID of our model and of the texture that's being applied to that model. We also do scale. As I've said, it's different how you exported the 3D model, so the 3D model might be too big for this scene. You just have to scale it down or scale it up, depending on what you want to do. And as you can see, the rotation here is exactly the same amount of degrees that I did in the example number 2. So I still had to move the imported model with the x-axis. So what we do here is we add a camera. We didn't add a camera before, but we're adding it here. Why? So we can look at the element from a different perspective, because we added the element on x, y, z 0 position. So if we add the camera at the same position, you actually would be with the camera within the model, so you wouldn't be able to look at the model. So this is why the position of the camera is changed. And that is this. Okay, so now we've seen VR on the web. But where is AR in all of these things? That's where AR.js comes on scene. So it's basically, as it says, like the short name, augmented reality for the web. Here we're using AR.js with a frame. So we actually have like a stack of Webgl, Three.js, A-frame, and AR.js. So you can see like how this stacks on top of each other. So like it basically works on any phone with Webgl and WebRTC. It does have some minor iOS issues. So this example that I'm going to show will probably work perfectly fine on your Androids, but on your iPhones, I advise you to use it in Safari. It has a problem with iOS. They said that they will update it with the latest version. They didn't. But hopefully this will be changed soon. So it works on Safari. Of course, AR.js is open source, so anyone can check out what they're doing. You can contribute. It's pretty fun. So we have an example number 5, which will demonstrate a simple AR.js scene with a texture as an asset. So what we're doing here is we're not importing a 3D model. We're basically creating a box where we apply a texture and we're projecting it into AR. It doesn't work, right? I see you're testing it on your phones and it doesn't make a lot of sense. Just wait, it will. It allows us to cast the element on a surface template image. So this is one way of detecting where to place the element. Since we don't have any surface detection, any mapping, we're doing this on a template image. So when we open example number 5, you will see me. That's it. So we have a simple template image, and when it's being here, you can actually see the 3D model, or like the box, which has a texture all around it. So as I move this, it actually moves with it. So as you see how it bounces, it's not really bouncing, it's lag, but it's fun. It's fun to think that it bounces. So yeah, but of course it's not fun if you don't try it. So it's not over, but thank you. So you just need to point your phone to this and you should be able to see it. It's not so fun as like you having the paper in your hands, but it still works. Interesting thing, like when this first started, we had an idea in our company to send Christmas cards. So we basically sent an email with the QR code. People scanned it, and we hosted AR.js web app where they basically run the solution and then again just placed their phone looking at the logo of our company and they saw AR Christmas card. So it was pretty interesting to do. People found it fun. So let's see how this looks in our code. So this is example number 5. As you can see, this is the image that we're using for the template. So you have to point your phone for it to detect this image. This is a default image in the library. So you actually have to use this image if you want to display something on it. So this can be changed, of course, but it's not so easy to change. Basically, you can set up whatever you want, but it has to have a high contrast. So working with something really colorful probably won't do the trick, or it will in some certain cases. So here in the assets directory, I think it's this logo, we have a simple JPEG image that we're using as a texture. In the index HTML, we're loading A-frame and we're loading AR.js for the A-frame. This is some short way of importing some AR toolkit. You don't have to use it. Here we're saying in the A scene that we're embedding AR.js into the scene. So this is a way of telling A-frame that we're actually using AR.js and that we actually want to place our objects that are in the scene to some marker. The marker that we're using is the hero marker that you've seen. And we're still loading the assets similarly like we did in the previous examples. So we're just setting an ID named texture to the image, and we're later using this texture to place it onto the A box element. So with this, the A box will get the texture on all sides of the box. In the A marker tag, we're basically telling A-frame that all of the elements that are in the between the A marker tags should be projected onto that marker. And which marker it is, we're saying here. So it's a hero marker. As I said, this can be changed, but you have to play around a little bit with it. So what we did then is we added our camera, and that's it. So everything is still in our A scene, and we've imported our box. So of course, importing 3D models that were exported from 3D Max or something in OBJ file or any other is fairly the same. So here we've shown like how to do it with the texture on an A box, but in the previous example I've shown how you can do this in VR, not in AR. It's pretty much the same thing. You just have to watch the scale and the positions of the elements, and everything should work. So we've talked about VR, AR, but where is mixed reality in all of these things? I generally tend to explain things to programmers with rubber ducks. They said it's useful. Basically, VR is projecting objects into a virtual scene, of course, as the name says. Augmented reality allows us to project objects into the space that we already see. But mixed reality allows us to have the interaction of the objects we import with the environment we're currently in. And this is something that's being worked on with companies such as Oculus, HTC, Microsoft with their HoloLens projects, and many others. So in order for this to work, our hardware, of course, has to be a little bit different than it is right now. To be able to detect the types of objects, like to be able to differentiate the tables, the windows, the walls. Doing that just in the code with algorithms won't be quite enough. Like, hardware needs to be very thoroughly thought of and implemented properly. But this is something where we're going at. So until recently, we had something called WebVR. Now we have something called WebXR. So WebXR represents an API for accessing virtual and augmented reality devices, so includes all the sensors and head-mounted displays on the web. So it basically can access the IMU units on the hardware. It might be confusing for some of you if you ever did something with the WebVR. So now I'm talking about WebXR. What happened with WebVR? Well, nothing. WebVR ceased to exist, so now only WebXR exists. And it's being heavily developed by the Immersive Web Group. So it kind of refers to all hardware applications, techniques used for virtual, augmented, and other related technologies. So it should support all head-mounted displays. So independently, if they're transparent or utilize video pass-through, like we did right now with our phones, it should support all of these things. It should support mobile devices with all the tracking the mobile device has, fixed displays with tracking capabilities, and many others. So in 2017, Mozilla shipped the WebVR API in Firefox. And immediately, Oculus browser and Samsung Internet shipped WebVR for the Gear VR hardware. And Microsoft shipped WebVR in Edge browser. So like immediately after that, VR frameworks such as A-Frame that we saw today, React VR and others gained popularity because we've been able to develop VR experiences on the web. And of course, many other tools that appeared with it. So in 2018, people realized, okay, maybe VR is not enough, right? Because we're going to maybe want mixed content. Maybe we'll want to support VR, but also AR, or maybe something in between. So they decided to rename the API from WebVR to WebXR to provide access both to augmented and virtual reality devices. Currently, Immersive Web Community Group is working on this. So there are a lot of people, both independent developers, but developers from Google, from Oculus, and many others that are working on this currently. There is WebXR Viewer for the iOS and others. So you can actually play around with WebXR currently, but it will be very easy to develop solutions today that might not actually work tomorrow because it's being currently developed as a standard. So if you ask me when are we going to have a stable WebXR API, I cannot answer that, but I can maybe assume that it will be maybe in 2 years, I would say, but we'll see. So this is something where the web is going with virtual and augmented reality. So this is the road we traveled today. So we went from simple Webgl and Three.js to the A-Frame where we enabled VR, to AR.js where we had an augmented reality on our browser. And now we're going to WebXR. WebXR is something that represents this future, and after that, who knows. So some of the examples that are currently working with WebXR, like Mozilla for testing, developed an A painter. The solution itself is not that fancy, but what is pretty interesting is this uses the controllers from HTC Vive. So it actually uses already existing hardware controllers from another device in the browser. Google also had some testing platform where they basically detected the surface, so they were actually able to move the objects on the surface and cast it into space. This is a solution, I think, very useful, like a business card. So imagine giving someone just a name and it will recognize how to open this, and I guess you would be hired immediately, even if you don't know these things. But yeah. So that would be it. Thank you very much.
Thank you. Time to question. Any questions? Oh, we have one.
Thank you. Do you have examples for different markers, not only hero marker for air?
Yeah. It's a very interesting question. I have a couple of examples that we did for the business, for the card, like Christmas card for our company, that we actually had to basically slightly redesign the logo of the company in these purposes. So like we had to go with black and white, and we had to integrate the marker differently into the surroundings. But yes, of course, this can be done, but you have to be really careful, like if you really want this surface to be detected properly. So this works, yeah.
Hi, and thank you for your talk. I want to ask you about your real-life products, maybe using this technology. And one important question that I want to ask is the performance on the web, because I think that it's much better to use some native technologies like Unity or something like sure. Apple's products. And what do you think about performance, and do you have some real-life products with these technologies?
Yeah. So I'm gonna first maybe answer the first part of the question. So what I'm currently doing with this, my personal experience, as I said, like I'm porting mapping library to augmented reality. Then we come to other part of your question, because like if you're doing a research and if you're developing something new, of course you would like for that to actually work. So you like to have it performant. So this is where I have most of my problems, because the approach that I'm taking there is the first initial prototype was basically casting one canvas into a canvas that's displayed in the VR. So if you're running two canvases, where one canvas is basically loading the map and the other canvas is taking snapshots of the first canvas, you have serious performance issues. Like you can actually move over the scene and do things like that, but if you actually, and you will have 60 frames per second, maybe slightly less, but if you try to, let's say, zoom in the map while you're moving, the frame rate drops to 5. And that's good if it drops to 5. So actually, like, what I'm trying to do now is to actually create a library where I can basically do what Google Maps or Mapbox are doing, like arranging the tiles in the canvas to create a map. I need to do that directly onto the canvas that's projected there, so I can get close enough performance. But if we're talking about some commercial usage and stuff like that, I personally don't think WebXR is ready for things like that, but it might be in a couple of years. And right now, of course, building native solutions for something complex, some complex games or some, I would say, interactive demos, I would go with native, definitely. But for some simple examples, I think this can do the trick, yeah.
Any other questions? I have one.
So you've talked briefly about the spike in the market cap of AR applications, and why do you think so? Like, what are the main reasons why this should happen?
The main reason behind this peak is basically bringing 6 degrees of freedom without any connection to the computer. So we can see that next year Oculus is going to release Oculus Quest in March. That will cost around $400, and you'll be able to get with $400 a device that's wireless and that can actually map the space. So the wireless part is something that should bring virtual reality to like more people with decreasing the price. Like right now, if you want to buy HTC or the Oculus Rift or something, you have to pay a lot of money, and still you have to own a really good computer. With something like Oculus Quest and others that will follow, this should be bridged very soon, and that's why they think like the market is expanding, the developers are building new applications. There are like interesting facts that contribute to this expansion. Like, I didn't make the statistics, but I really believe it. Yeah.
You have one question?
Hello, thank you for the presentation. As we've heard, you are currently a PhD student. So I wanted to ask, do you have your final project ideas or another projects that you have developed during your enrollment?
Sure. That's the project that I talked about with the map. There's one paper published in IEEE library, so you can actually just type my name and you'll get the project. And I think it's called WebVR real-time map something. I can't remember actually the exact title, but it's an IEEE, and soon enough one more will be published, and that is like my road to the PhD itself. So you can actually read that paper. I'm planning to release the entire project that I did on GitHub, but I won't do it until it's performant enough. So I don't want like thousands of issues for something I already know. So yeah, that's it.
Any questions? We have 2 questions.
Hello. Thank you for your talk. My question is, what will happen if we have not compatible browser for this plugin? And do we have some fallbacks or something like callbacks if it happens?
You're talking about A-frame or A-frame? Well, we won't use A-frame probably, or A-frame will have to evolve and to follow the specification that WebXR is going to provide. So WebXR should standardize the API regarding all the hardware the devices are using. And libraries that will use WebXR will probably, if the standard is applied, will probably have to just apply to it. I'm not sure if A-frame will be that library. Right now, you know, fallback for building such solutions, you know, it's pretty much risky. Like you already saw, some of you, like you used the app, some of you had probably maybe like IMU was shaking or something, the image wasn't stable enough. But as I said, like these are the beginnings, so.
Thank you. Hi. I was curious about the community that stands behind these technologies, and I was wondering if you can name perhaps a couple of open source projects that we could learn from or participate in.
Yeah, sure. I mean, the immersive web group, which is basically a W3C group where anyone can join, There are people, as I said, like from Google, from Mozilla, I think also from Microsoft. I know no one from Apple. For some reason, they're not in this. They actually are very, very active, and anyone can join. As I've said, like, you should join only if you plan to be active, because they really spam my email. And like most of the meetings they have are always remotely broadcasted, but they physically meet in California. So like there's also a way to contribute to the project, but yeah.
Any questions? If you have any additional questions for Marko, you should proceed to the discussion zone. I think she saw some. She can give you some interesting examples.
I can. It's not a problem. Of course. So like if you have any other questions, just please contact me after this. And yeah, thank you very much.